This is Venus. At first glance, it looks like Earth's twin. Nearly the same size, nearly the same mass, a rocky world wrapped in clouds. If you didn't know better, you might think it was just another version of our planet. A slightly hotter one, maybe. A little closer to the sun, but still familiar, still safe. That assumption is one of the biggest mistakes we ever made, because Venus is not Earth's twin. It is Earth's warning, and the deeper we look into it, the more unsettling it becomes. Imagine standing on its surface, except you wouldn't be standing for long. The pressure is over 90 times that of Earth's atmosphere. That's the equivalent of being nearly a kilometer underwater in Earth's oceans. Your body wouldn't just feel heavy, it would be crushed. And the temperature? Around 465 degrees Celsius. Hot enough to melt lead. Hot enough to destroy electronics in minutes. Hot enough that even spacecraft designed to survive it barely last an hour. The longest any probe has survived on the surface is just over 2 hours. 2 hours. That's all it took for one of the most hostile environments in the solar system to completely overwhelm human engineering. But here's the twist. Venus wasn't always like this. For decades, scientists believed that Venus might have once had oceans. Vast oceans of liquid water. Clouds that rained. A climate that may have even been habitable. In some models, Venus could have remained Earth-like for billions of years before everything went wrong. Let that sink in. A planet nearly identical to Earth, that turned into this. So what happened? The answer is simple and terrifying. A runaway greenhouse effect. Carbon dioxide built up in the atmosphere, trapping heat. As temperatures rose, oceans began to evaporate. Water vapor is itself a powerful greenhouse gas, which trapped even more heat. More heat led to more evaporation. More evaporation led to more heat. A feedback loop with no off switch. Eventually, the oceans were completely gone. Broken apart by solar radiation, hydrogen escaped into space, and oxygen reacted with the surface. What remained was a thick, suffocating atmosphere of carbon dioxide and clouds of sulfuric acid. A planet that essentially cooked itself to death. But that's only the beginning of the story. Because Venus doesn't just have a thick atmosphere. It has one that behaves in ways that shouldn't be possible. High above the surface, at around 60 kilometers altitude, something bizarre is happening. The entire atmosphere is rotating around the planet at speeds of up to 360 kilometers per hour. That's nearly 60 times faster than the planet itself rotates. This phenomenon is called superrotation, and for a long time, we had no idea how it worked. Imagine winds so powerful that the entire sky circles the planet in just 4 Earth days, while the surface below takes 243 Earth days to complete a single rotation. The sky moves faster than the ground. It sounds impossible, but it's real. And then there's the rotation itself. Venus spins backward, opposite to most planets in the solar system. On Venus, the sun rises in the west and sets in the east. But it gets stranger. A single day on Venus, one full rotation, takes longer than a year. Its orbital period around the sun is about 225 Earth days. Its rotation period is 243 Earth days. That means a day on Venus is longer than its year. Let that sink in. The sun rises and takes months to cross the sky. For a long time, we thought Venus was geologically dead, a static world. No tectonic plates, no shifting crust, just a thick atmosphere sitting on top of an unchanging surface. But then we started to look closer. Radar mapping missions revealed vast volcanic plains, massive shield volcanoes, lava flows stretching for thousands of kilometers. And then came the real surprise. Evidence that some of these volcanoes may still be active, right now. In 2023, new analysis of data from older missions suggested that vents on Venus had changed shape over time, that lava flows had expanded, that something was erupting, not billions of years ago, not millions, but possibly within the last few decades. Venus might still be volcanically alive, a planet covered in pressure, heat, and clouds that is still reshaping itself from within. And that leads to a deeper question. If Venus is still active, what's driving it? On Earth, plate tectonics help release heat from the interior. On Venus, there are no plates. The crust is more like a single unbroken shell, so heat builds up beneath it. And when it finally escapes, it doesn't do so gently. Some scientists believe Venus undergoes periodic global resurfacing events, the entire surface melting and reforming over relatively short geological timescales. Imagine a planet where the ground beneath you doesn't just shift, it resets. But perhaps the most unsettling mystery of all isn't on the surface. It's in the clouds. For decades, scientists detected something strange in Venus's upper atmosphere, a chemical imbalance. Specifically, the presence of gases that shouldn't coexist under normal conditions. And then, in 2020, a claim was made that shocked the scientific world. The possible detection of phosphine. On Earth, phosphine is associated with biological processes, microbial life. The idea that it might exist in Venus's clouds raised a question that sounded like science fiction. Could there be life on Venus? Not on the surface. That's impossible. But in the upper atmosphere, conditions are surprisingly mild. Temperatures and pressures similar to those on Earth, floating within the clouds, shielded from the inferno below. It's a narrow band, a thin, habitable zone suspended in an otherwise deadly world. The phosphine detection is still debated. Some studies support it, others challenge it. The honest answer is that we don't know. But the fact that the question even exists changes how we see Venus entirely. And then there's the lightning. For years, scientists argued over whether Venus even had lightning at all. The thick clouds made direct observation difficult, but multiple missions have now provided evidence that lightning does occur, possibly even more frequently than on Earth. Lightning in an atmosphere of carbon dioxide and sulfuric acid, a sky that flashes and roars above a surface hot enough to melt metal. But here's something even stranger. Venus doesn't have a global magnetic field. Earth's magnetic field protects us from the solar wind, deflecting charged particles from the sun. Venus has no such shield, and yet it still has an induced magnetosphere. The solar wind interacts directly with its atmosphere, creating a kind of temporary magnetic barrier. It's weaker, more chaotic, and it allows particles from the sun to strip away the upper atmosphere over time. Venus is slowly losing what little remains of its original water. Atom by atom, molecule by molecule, a planet being eroded by its star. So what we're looking at is not just a hostile world. It's a world in transition. A world that used to be something else. A world that might still be changing in ways we don't fully understand. A world where the surface is crushing, the sky is racing, the clouds may hide chemical mysteries, and the past is written in a language we're only beginning to decode. And we've barely explored it. Only a handful of missions have ever successfully studied Venus up close. Most didn't last long. The Soviet Venera landers gave us our first glimpses of the surface. Cracked rocks, orange skies, a horizon blurred by thick atmosphere. But their lifespans were measured in minutes, hours at best. We have no long-term presence there, no rovers, no continuous observation, just brief visits to one of the most extreme environments we've ever encountered. That's about to change. New missions are being planned. Orbiters, atmospheric probes, even concepts for floating platforms that could drift within the more temperate cloud layers. Scientists want to understand what happened to Venus, how a planet so similar to Earth became so different, and whether the same fate could ever happen here. Because that's the uncomfortable truth. Venus is not just an alien world. It's a possible future. Not necessarily for Earth as it is today, but for planets like it. The processes that transformed Venus are not unique. They are part of planetary evolution. Push the conditions far enough, and a habitable world can become uninhabitable. A stable climate can collapse. An ocean can vanish. An atmosphere can turn against the surface it once protected. For decades, we looked at Venus and saw a failure. A dead end. A cautionary tale we didn't need to think too deeply about. We were wrong. The more we study it, the more it challenges our assumptions about climate, about geology, about the limits of habitability, and possibly about life itself. Venus is not just hot, it's not just hostile, it's not just strange. It's a planet that used to make sense, and no longer does. And the deeper we look, the more it feels like it's hiding something. Not because it wants to, but because we're only now learning how to see it. And that's it from this video. See you in the next one.